So why was the computer bad at making art? Because it always followed the same procedures, right? In this tutorial, we'll look at how to procedurally generate a table in Houdini. This will be a basic introduction to Houdini as well. So if we were to take a look at this table that I have created, all of them is procedural. So I can change the height of the table, I can change the length of the table, I can make it small, or I can make it, stretch this way. Same with the thickness as well. I can change the thickness of the table as well. So this is the end goal that we are trying to create. So it's very easy and rapidly artists can prototype different models of table within Houdini. But if you were to take a look at the traditional approach, first say in Blender, although I don't despise Blender because Blender does have a geometry node in which you can procedurally actually create the tables as well. But if you were to take a look at the procedure of the traditional modeling, so you would create a whole bunch of cubes. So this is one cube, another cube, another cube, another cube, another cube, another cube, another cube, right? And the problem with this is if I were to make it small, then this stuff doesn't translate well when I change the size of the table, right? So that's why we'll use procedural modeling, in which we don't have to redo editing other stuff extra when we want to change the constraints of the table. So with that, I will first go ahead and click on new. I'll discard. And so this is the scene view in Houdini. I can the left click with the mouse and pan around and see. This is the node view where we'll mostly be doing our work. So when you start with the object context. So what I can do is on this, it says press tab to add object. I can do tab, and then I'll add a geometry node. And geometry node is basically, think of it like a folder or container. So this would be a table, and I will double click inside, then we'll go into a geometry level. Okay, so to start, we know we need some sort of tabletop. And we'll start with the primitive shape called grid. So again, I'll go into this node view tab and then click on grid, and I have the grid. Now this is too big, so for me to focus, I can go in this scene view and press F, and this will help me to focus. Now the size is, we'll be customizing it. For now, we'll keep it to 1 by 1. Again, I'll press F, and this is too many divisions. We don't need that many divisions in the table, so it would be 2 by 2. So we have a nice looking tabletop. Okay, and I can say this is a tabletop. Okay, now every time we want to make some edit or we want to use a procedural node, we can use, instead of doing the edit in here, what we'll do is we'll use this transform node in which we want to make an edit. Okay, so this would be table size. Okay, now if we were to think of a table as a system, if I were to go back to this Blender reference, shameful that I'm using a Blender reference for Houdini. You can think of a table as a flat grid with 4 lines pointing out from it, right? Of course, those lines have thickness, or if you were in Blender, you use a solidify modifier. So we'll use the same system in generating that table. So here we want the line coming from each point of this grid. So let's add another node called line, and we can view this because right now the view is in here. So I can go all the way to this end and click, and then I can see a line. Okay, again, I can F to focus. Yeah, I see the line. Same way, we will use the transform node to, maybe we will double click and say this would be the leg height. Okay, now transform is basically the translation. So using this, we can rotate, scale, all that good stuff. So we have the line, and if I were to go in here and if I were to increase this, sorry, maybe it is still displaying that. Okay, now if I would increase this, you can see that I can procedurally use this slider and change the size, right? Now what we can do is we want to copy this line to each point of that tabletop. So there is a node called copy to points. So I'll do that. So I can copy this in here. So if I were to see this, now looks like our line has copied into there are 4 lines actually. So only thing we need to do is we might have to change the translate. So now you can see there are 4 lines. Okay. So, and if I want to see it in context, so this is what it looks like right now. Okay. Yeah, let's see. These lines look really thin. So what I can do is I can add a polywire node. I could do it in here. So maybe the wire radius would be 0.9, and I think this looks very straight and rough edge. So let's increase the division by 10. Okay. Now still, this is the outline of the table. Now we have that. I'll remove this template flag, so it was the second. So this would view, this would templatize it. Okay. So I'll remove that. I'm back here. Now what I want to do is I want to move this table to top here. Okay, so I'll add another. So since we are doing the transformation, basically we are translating it, I will add another transform mode, and then I can say move table top. Okay, now what I want to do is in here, if we were to take a look at this flag, right, you still see this. So what I can do is if I were to translate it to 1, it goes up. Okay, now I want this translate to be the same as the line height. Yeah, so this would be here. We see that it has translated. So what I want to do is I want to get the value from the line height. So this would be the uniform scale, right? And whatever scale that we chose in here, so I think maybe I should move this after we do that, because it looks like okay, now it works. The only reason it was scaling that even the polywire, which I don't want. So basically I want the line height, and what we'll do is we'll use this uniform scale. So I'll go in here, right click, and then we'll do copy parameter. We'll go up to the move tabletop, and then in here in the translate on the Y, what I can do is paste relative reference. Okay, now let's templatize it. Now you can see it. Okay, to see it better, what we can do is I can do a merge node, and here I merge this two, and let's view this. Okay, now I think we have the table, but still the tabletop is very thin, and what we can do is we can add another thing I want to do is actually on this tabletop, on the scale, let's do like 1.4 by 1.2. Okay, so it is not just, you know, touching by the edge. Maybe I can go 1.5. Okay, so that it's better. Okay, now what I can do is I can add a poly extrude in this top. So on this tabletop, what we'll do is add another node called poly extrude, and there it is. Now if I were to increase the size of this distance by somewhere here, I think we have our procedural model. So only thing is I want to decrease the size. Maybe I want to keep it to 5. Okay. So another thing is the backside doesn't look like it is filled, so I can do is output back and bam. Now we have the table. So I'm actually using a right mouse click and dragging. So now this is a very procedural model. So only thing I can do is if I were to increase the size, you know, this would be the size of the table. I can decrease the size, and then the same with the scale. Maybe I want to change the X, maybe Y. So whatever way we decide, we can actually change. And then so there you go. You have a very procedural model in Houdini. And maybe in the next lesson we'll take a look at how to actually create maybe we can save this table and we can expose some of these parameters that we want the artist to play with, and maybe lock other parameters that we don't want. Okay. Yeah, but this would be all for this tutorial, and I'll see you in the next one.